Hello, everyone. The Wi-Fi just dropped on me and it couldn't load my slides, so I almost fucking had a heart attack. But well, I'm really excited to be here. Thank you so much, Cascadia, for inviting me, and thanks everybody for sitting here to talk about machine learning for front-end developers. So before I start, my name is Gerard. I am a front-end dev, as Jessica said, but I'm also a Google Dev expert and a Mozilla tech speaker. So if you don't know what these two are, you can ask me questions afterwards, but it's basically two tech community programs supported by Google and Mozilla for people who like to share knowledge in different ways. So it could be talks or workshops or blog posts and things like that, and you can get support for speaking at conferences and being part of a community of people who share the same passion. But I'm not here to talk about me. I'm here to talk about machine learning. So I don't know what you know and what you don't know, so I thought that I would start with a pretty simple definition to put everybody on the same level, and then we can go and dive a bit deeper. If we just look at a classic definition, it's basically giving the ability to computers to find patterns in data without being explicitly programmed. So I feel like sometimes when I just read a definition like that, I don't really quite get, what you mean. So let's talk about an example. I think that, I'm sure that you all know what it's like to receive spam emails. Maybe you don't really think about it because now they're filtered straight away in your spam folder. But if we think about that particular problem, at the moment, it is using machine learning to kind of look at all the content of our emails. And in the past, if you think about Gmail, for example, Google had access to like millions and millions of emails that everybody received. And using all that data from emails, we can find patterns in what makes a spam email and not, instead of having to do the manual check of like looking at specific terms that you're looking for in emails. For example, you could have spam emails of like Viagra or receiving millions of dollars or things like that. And instead of looking for particular terms in emails, it learns patterns from all emails received before and is able to then predict getting a new email, kind of predicting if it's a spam email or not. So that's what it means when it's kind of like finding patterns without telling exactly the computer what to look for. And at the core of machine learning, like the way it works is you create models that are basically functions, and models are created with algorithms. So let's talk about that quickly. If you start looking into machine learning and you read some blog posts or you follow some tutorials, you will usually come across these terms, these names of algorithms, like naive Bayes or linear regression and convolutional neural network, all these like complicated terms. But if you don't understand them, it's fine, me neither. But that's not, you don't have to understand exactly how they're implemented. What is important is knowing what they're good for. And even before that, before talking about different types or the names of the algorithms, you try to figure out what type of problem you're trying to solve. So let's talk about that instead. In machine learning, there's three different types of learning. So you have supervised learning, unsupervised, and reinforcement learning. For this particular talk, I'm only going to cover supervised and unsupervised, first of all because I don't have the time, but also because a lot of the problems that you will want to solve if you get started in this fall into the supervised and unsupervised category. So reinforcement, you can kind of leave it for now. So supervised, it's basically creating a predictive model based on a set of features and labels. And there's three important terms in this definition. First of all, what is a predictive model exactly? What are features and what are labels? So again, when I read a definition, like I think I need an example that I can relate to. So this is what I tried to do. The example for this particular type of learning is predicting the price of a house. So we're in Seattle right now. Let's say that we're lucky enough to own a house and we want to sell it. But you have to know how much you should sell it for to optimize when it's going to be sold, and to make sure that you're not, like, you get as much money as you can. And in this particular example, so what you have access to is the data of all the houses in Seattle, right? That's all you have. And you're trying to predict the price at which you should sell your own house. So the labels here is how you would classify each entry in your data set. What we're trying to predict here is the price. So using the data of all the houses in Seattle, we know their price. So you can imagine a spreadsheet where on the column, your label is going to be the price of all the houses. And the features is the characteristics of the entries in your data set. So for houses, it could be the number of rooms, number of bathrooms, number of floors, the neighborhood that it's on, like a lot of different characteristics. And using these characteristics and the price of each house, you're going to use algorithms to create a predictive model. So it's going to try to find the correlation between the characteristics of a house and the price at which they're worth. And a predictive model is, in the end, the mathematical representation of the outcome of your training. So in more practical sense, it's going to be some kind of function that will take as parameters the new characteristics of a house that it's never seen before. So our house, for example. So the predictive model is something that you're going to be able to reuse. And having learned correlation between characteristics and price, it's going to be able to predict to you the price at which you should sell your house based on the ones that are around. So this is for supervised learning, but then unsupervised is the ability to create predictions based on a set of features. And that's the end of that definition that's really important because it's the main difference. You don't have labels anymore, you only know features. And if we think about our example of predicting the price of a house, that wouldn't really be unsupervised learning, because if you're trying to know at which price you should sell your house, but your program knows nothing about what a price is, it can't just like make one up like that. So for this type of learning, the example would be predicting customer behavior. So unsupervised learning is going to cluster things together. If we think about when we go to the shops to buy our groceries, they have data about when I'm going to the shops, where I'm going to the shops, how many times a week, what I buy, and based on all of this data, they probably know my gender, my age, my socio-economic background, and using all of these features about each of the customers, they don't have to know exactly who you are, but they can cluster people together, so I would probably belong in a certain category, and using looking at what other people have bought in the same cluster as me, they can use that for marketing, to know what I probably like based on what other people have liked as well. So this is the main difference, and the first thing that you have to think about when you want to use or solve a problem with machine learning, because then you can go and pick algorithms, but the first thing that you have to do is figure out what type of learning that you're trying to do. So let's talk quickly about some applications, because that was kind of theoretical, but what can you actually build with this? I just put together 3 examples. There's a lot of cool stuff that you can do. That could be an entire other presentation. But for this one, I'm going to start with the first thing that I saw done on the web. That was an experiment by Sarah Drasner, where she used one of the Microsoft Vision API, so using machine learning, to upload images and generate automatically alt text for images that you can then put in your code. So if you're thinking about a single image, yes, you can do that manually, but if you're thinking about platforms where you have a lot of images and you have to generate these, as developers, maybe this is not where you want to spend your time. You don't want to spend your time finding the right text to add in images or image tags. So you can actually leverage machine learning to do that for you, so that then you can focus on solving other problems. So this is just an experiment, but this is the kind of things that you can build. Another one that I thought was pretty fun, or actually quite useful, but it's called Not Safe for Work.js, where you can upload images again, and it will tell you the probability of it being not safe for work. It was quite interesting to me, because before being a dev, I was in marketing, and that would have been really interesting, because I used to work with brands where they wanted to put together a competition where people could upload photos on on their Facebook page or something, and you can tell people only upload selfies or something, but you can't really force them not to upload something else. And instead of having a person having to sit down manually and filter through images to make sure that you don't have naked pictures or whatever, you could actually use that kind of tool to do the pre-check for you, so that again you can move on and do the actual code or whatever other work, rather than spending your time sitting down and looking at all people's pictures. Another one that goes a little bit another way, but it's around using machine learning to help with accessibility. I'm really interested in trying to find ways that machine learning can actually help people. And this particular example was around the future of interactions with voice. So with voice interaction, you can talk to Alexa, and you can say, hey, Alexa, or something like that. And you can ask a question. But what about people who can't talk? Are we going to put away a huge part of people who have some kind of speech impairment or something, and we're only going to focus on people who can speak? That's not quite right to me. So this person, I always say his name very wrong, but I'm going to try anyway, Abhishek Singh, he wanted to prototype something around that problem, so that he actually used the camera of the computer to train an algorithm or a model to recognize certain gestures that he mapped to words, so some kind of sign language, so that then on his laptop it would communicate the question to Alexa, and then Alexa would reply. So the input would be coming from the camera that you train, and then you still are able to interact with an Amazon Alexa, but in a different way. So I thought that was a really interesting example. But now let's dive deeper into machine learning actually in JavaScript. So the first thing that I'm going to cover is the why, because every time I build personal projects, people are like, why do you do that? Well, let me tell you. So I think that it makes it a lot more accessible. So I know that machine learning, when you think about it, you probably think about Python first, not JavaScript, and that's understandable. But having it, being able to do that in JavaScript means that it's now open to all the JavaScript developers. It means that you can, instead of having to learn another language and the concepts around machine learning, you can just, it's like learning another framework. It's like if you migrate your app from React to Vue or something. If you don't know Vue yet, you can just read the docs. It's going to be just a different syntax. I said just, but it's not really just. But it's like you can learn the other syntax, and it makes it easier to get started. So it kind of like you don't have that many blockers that avoid you from trying something. The other reason that I think is important is rapid prototyping. When you want to convince people that your idea, you have an idea that is good or that is worth spending time or money on, being able to prototype something and show it to people is probably the best way that you're going to convince them about an idea. And I find that JavaScript is a really good language to prototype things. Like I do a lot of my personal projects are using JavaScript because like it's something that I'm really comfortable with, and you can just have an experiment where you can just send a URL to somebody. They don't have to install any kind of software. You just send the URL, you build something very quickly, you don't care about the quality of the code. And then if you actually are convincing people, then you can spend money and time on developing a more production-ready prototype. And finally, there's a big ecosystem. So it has grown a lot. I think at first there was maybe 1 or 2 main frameworks, but now a lot of people are building tools that are, they're porting what is in Python. They're building JavaScript modules out of it, and there's actually a lot that you can do. So that's like my main 3 whys. But now, what can you do? So there's 3 main things that you can do. You can import an existing pre-trained model. So it's a model that has been trained with a lot of data already for a specific purpose, and you can just load it and reuse it. The second one is retrain an imported model. That's called transfer learning. So you're going to use the model as well, but you're going to give it some, like your own data. You're going to kind of like retrain the algorithm. And finally, you can do everything. So you can define, train, and run the models entirely in JavaScript in the browser. That might not be a good idea, but you can. In terms of tools, you might have heard of TensorFlow.js, which is basically the JavaScript version of TensorFlow, supported by Google. This is the one that I'm going to talk about when I'm going to show some code samples. But at first, when I started, I was actually quite confused with the documentation of TensorFlow. I didn't really know about machine learning, so some terms I didn't quite understand them. So I played around with ML5 that abstracts a lot of the more complicated parts, and it allows you to get started really quickly, and they make it a lot simpler to understand. Then you can leverage the tools from Amazon or Google or Microsoft if you don't want to write code, but you just want to ping some APIs. And then finally, if you want to do something a bit more specific, the M in the middle here is for Magenta.js, where it's actually a framework especially to do music experiments with machine learning. So you can have algorithms creating music, or you can jam with an algorithm, basically. So you have more specified frameworks as well. OK. This is the part where it's going to be fun. So demos and code. So I talked about what you can do, and now I'm going to try to show you some demos of stuff that I built, and also some code samples, so hopefully it makes a bit more sense. So first of all, I talked about using a pre-trained model. So for this particular project, I built something that I called Can I Recycle That? Because I didn't know how else to call it, but it's about recycling, so it's like very creative title. And it's, I'm going to open it just to make sure that it's loading and that the internet did not fail. OK, cool. And the purpose of this app was to, so I want to get better at recycling, but I don't always know where things should go, like in what bin. So I was thinking, well, I can probably automate that somehow. And this is where I can see that machine learning can be actually quite helpful to solve some problems. So I'm going to try to demo. So if I start, it should, OK. So, all right, so I have it works on the phone. You're supposed to use it on your phone, so you're supposed to be able to walk around and like snap stuff on your phone. But for the purpose of the demo, I'm going to show the laptop. So I have a bottle of water, because it works well with water. And if I click on, is this recyclable? No. I mean, see, well, if you know a bit about computer vision, the issue is that if it sees me, no, oh, okay. So is it a bottle? Oh, it's a bit small, but you can, I can share the links later. So it's like, is it a bottle? And then if I click yes, it's like, it's recyclable, throw it in the yellow bin. So I don't know if you have yellow bins here, but in Australia, they're yellow. And so you can just change that, that's fine. But yeah, so I was thinking, okay, I'm just really going to close this because like, ooh. Yeah, so here, as I said, we're using a pre-trained model. So the way, for the code sample, you're going to start by requiring, I use the Coco SSD model. That's an object detection model. So it has been trained with a lot of different objects, and it's good for image recognition. What you import then is TensorFlow.js. You start by loading the model, so you're able to use it. Then you look at the camera feed from the webcam, and you use some of TensorFlow's built-in methods to look at all the pixels in the webcam. You kind of do some transformation so that the data structure is something that TensorFlow.js can understand. And then you give that processed image to the model, you call the detect method, and you get back a prediction of what it should be. So you get back a label of bottle or person or phone, and that's basically it for the prediction part. Then you can add whatever code for your UI, but in terms of detection, these lines should work. I mean, yeah, maybe I forgot one or two, but it should, like, that's all you need to do image detection. So that was for the first one. And now, second, transfer learning. So what I said about that is that you reuse a pre-trained model, but you add your own samples. And for this one, I have to use my slides again. I built what I called the teachable keyboard. Ooh, okay. And this one is, I wanted to be able to write on the computer, but without using my hands. And it's on top of a project called Teachable Machine that I'll talk about right after. But what is happening here is that I'm going to start a training and live in the browser. So the camera feed is small, but you actually don't care about it. Just for the demo, I wanted to show you what I'm doing with the camera and the screen. But basically, so I'm here in front of my laptop, and if I click right, I'm going to record some samples of right. If I go left, I'm going to down, and I'm neutral. And yeah, I'm just testing my predictions before I go, so down, left, right, and that's like done in like 10 seconds, you know? And then I go do that, and I have a keyboard on the screen, and I'm able to actually write things. So I'm not going to write something that makes sense because I didn't think about it. But yeah, so then you can change whatever UI, but it means that in less than 30 seconds, I actually train an algorithm to recognize new samples that it's never seen before, retrained it live, and now I'm able to play with that in the browser. So in terms of code, it's a little bit more than before, but we start with the same concept. So we import a model. This time, I'm going to use the MobileNet module because it was part of the Teachable Machine repo. I kind of like just ripped some code off. You import TensorFlow.js, and then you import also a classifier because we're going to need it to reclassify on top of the model that you loaded. Then you have your variables, where it's like just a number of classes. The image size has to be 227. It's hard-coded because the bigger the image, the longer it's going to take to retrain. So they just hard-coded to 227. And the top k value, the k value for the k nearest neighbor, that's a bit arbitrary. You can, don't have time to explain that, but I wrote 10, but it can be anything. And then your classes is what you're actually trying to train. So again, you could change that and do whatever you want with it. Once you imported everything, you create your classifier, you load your module, you do the same as before, where we look at the pixels from the camera, and you kind of merge all of this, all of the new samples, with the MobileNet module that you imported before. And then you give all of this to the k-nearest neighbor, you kind of add the examples, and you call the predict class methods on the k-nearest neighbor with all of this new data. So the data from the model that you loaded and your new sample data. It was going to give you back an index of the prediction. And we had before our classes variable that had right, left, down, and neutral. So depending on the index that you get back, it would be the position in the array of classes. And in the end, you can dispose of the image that was our camera feed, because once it's been retrained, you actually don't care about keeping that in the code or in memory or anything. You can move on. The model has been retrained to understand your samples. So I talked about Teachable Machine because this is what I built my thing on top of, but they just released yesterday version 2, and it's a tool where they allow you to try very quickly to understand, how that works. You can save some samples of sound, of camera feed, and things like that. And it's just like a way where you can tinker a little bit with machine learning before knowing if you want to go further or not. So I would really recommend having a look later. So then finally, we're talking about doing everything in JavaScript. And for this one, I built something from scratch that I'm always getting a bit nervous about, but let's do it. I built a WILLY detector. So before I start, it's not pictures. I don't know, because I don't know if the word WILLY is, it's basically a penis, but it's not pictures. Okay, so don't kick me off the stage. I would never show pictures. I don't want any pictures. And yeah. But the reason why I did this is because I wanted to work on something else, where I wanted to allow people to collaboratively draw on a page, and then it would be projected on like a matrix of LEDs somewhere or whatever. And the thing is that I can tell people not to draw willies, but you know that people will. So instead of, I didn't want to sit down and be like, oh, I'm just going to like 24/7 like erase willies. So I was thinking, well, I can surely automate that, and I did. I didn't actually build the thing I wanted to build, but I built that and I was happy with it. So if I exit the slides again, I'm going to close this. All right, so the canvas is a bit small, but again, the bigger the image, it's going to take longer. And also, I didn't want to draw a massive willy, so that's like... All right, so what so for this particular example, so it works with candles and willies just because I didn't train it with something else. So I'm going to try with a candle first. It's really hard to draw like that. And OK, that's not a willy, so that's cool. So if I actually did build the thing, it would have not erased that one. But then if I do draw, well, yeah. Willy! I'm going to clear this. And what is cool about this is that I don't have to draw it like exactly where I put the pixels before or whatever. It just recognizes it looks at all the pixels in the canvas, and it was just recognized based on what it's been trained with. So let's talk about the training process. Because so I'm going to go through not the code samples, but the steps to build this. It's going to get worse. So I started by... So you need data. So you need to collect data, obviously. So I used the quick draw dataset that's on the right. That's a dataset by Google, where they asked people to draw stuff on the screen and then just save the samples. Obviously, they didn't ask people to draw willies, so I didn't have willies in the dataset. So I had to draw my own. I did not draw as many as what's in the quick draw dataset, because there's hundreds of thousands of samples, and I don't really want to draw 100,000 willies. I don't have the time, and I don't want to. But I draw a few hundred. That was enough. That was definitely enough. So first you collect the data. And then I hate this slide because, all right, you have to process and you have to transform the data. I'm going to go very quickly with this. So the reason why you have to transform your data, there's actually a lot of, like, it's not that much, it's not a stupid example. Like, it's very useful. So the one on the left is like when I draw on a screen, it was 200 by 200 pixels. But in the quick draw dataset, the sizes of the image is 28 by 28. And it needs to be the same size. So to be able to use to mix all the data together. So you go through this step where you process and transform and things like that. Then you split between a training set and a test set, because all your data at the moment that you have is already labeled. You know what a candle is, you know what a willy is, and you keep 80% of your training set to train the algorithm, and you're going to keep 20% of it to test it against the predictions. So when you run your predictions, you're going to use that new piece of data as like a test against your prediction, and if the accuracy is right, you're done. Otherwise, you have to retrain. So once you just split your training set, you can then pick your algorithm. There's kind of like no, you don't need to do it before, because now, once you've done all this, you know what kind of data you're dealing with, you know how much, you know what you want to do, so you can pick the algorithm later. I use the convolutional neural network because it works well with images. If you work with text, there's other algorithms and stuff. And then, so you tune some parameters. I won't have time to go into this, but you train the algorithm, you get the predictions, and depending on the accuracy, you repeat these 3 steps until you're happy with the predictions that you get. So that was cool, but if you work with stuff like that, you do need to know about some of the limits. I'm going to go quickly over this, but you need a large amount of data if you're building something from scratch. The quick draw dataset had, as I said, more than 100,000 samples, and it is normal to need that much data, because in the end, the computer, it doesn't know what things are. So you need a lot of data so it can find patterns quite accurately. It can take a lot of time to train your own model. That's why I'm saying that if you want to define, train, and run, like do the whole thing in the browser, maybe think about it before, because it will really impact the kind of user interface that you build. The only interesting thing that I saw is when you want to visualize the training process in the browser. So I think that's, for me, the only thing that you would do everything in the browser for. You have to think about the mobile experience, because some models are actually quite heavy. So for the recycling app, the object detection model actually was 15 megabytes. So that's a lot, obviously. But I'm sure it's going to get better. Things are going to get smaller, and then you will be able to build more performant applications. But you need to know about that before you start building something. In terms of liability, sometimes you don't really know how an algorithm decides or gives you a certain prediction. And depending on what you're trying to build, you could have some legal consequences if you can't explain why a model has made certain predictions. And then last but not least, a very interesting topic of bias and ethics in AI. I would really recommend looking into this because it's really, really interesting. And what I mainly want to say is that algorithms are not biased. We are. And what I mean by that is when you look at the news and say, oh, Google's algorithm is sexist or racist, it's like an algorithm is just a function. It's just a piece of code, and what it predicts on is based on all of the data that has been given before. It doesn't actually know things like we do. And what I mean is that the data that we give the algorithm is something that we created. And it doesn't mean if we create a sexist or a racist algorithm, it doesn't mean we're bad people. Like at first, what I like is that I think machine learning can actually teach us where we do things that might be wrong, or where we could actually improve as people, because it could really highlight some issues in the data that we create. And an example here around ethics is something that was a few years ago. I don't think it's the case anymore. But in Google Translate, you had a gender-neutral language like Turkish to a gender language like English, and words like cook were all of a sudden feminine, so she's a cook, and engineer was masculine. And it's not the algorithm. It's really just a piece of code. The issue is that it was probably trained on all of the content that we write that Google scrolls through, and that was, that's the content that's sexist or racist or homophobic or whatever. And that can really highlight where we could improve as people. And then finally, I'm a little bit over time, so I'll just show something quickly. I've given this presentation before where I showed something that I built. I changed it for this one because the one that I usually show never works, so it's always a bad way to end up the talk. But this time, I want to show you something that I built maybe a week or two ago to show you the extent of things that you can build with machine learning. So I never demoed it on stage, so we'll see if it's going to work. But I basically I used a clone of Beat Saber to actually play with your hand movements, because I'm really interested in trying to find ways to make certain tech, accessible. So the main purpose here was I don't have a VR headset, but I want to play, Beat Saber. And this is where you can really find ways to make machine learning something, well, that's not really helpful, that's just a game. But something that you can, it means that now, I don't actually need to buy any extra hardware. I have a laptop. Of course, it has to be a pretty performant laptop. I haven't tried it on any other machine. But let's see if it works. It should, because I tried it. But OK, so I should have hand recognition. OK, that's all right. And if I play, oh, yeah. Is it going to play? It's not playing. Well, I look stupid now. OK, it's been running while I was talking, so maybe it's just it's downloading the song. Oh, OK, cool. OK, so it's Bohemian Rhapsody, because it's one of my favorite karaoke songs. We talked about karaoke, so you know. OK, I'm a bit bad at this, but is this just fantasy? I'm looking for the beats. Oh, well, I missed it. Yay! Sorry, I'm having so much fun here. And so it is available. You can play. You can play with it, but it means that you can really. I'm going to stop it because. But it's good. So you can try it. You can try it later. It's available. The URL is there, but I can share it after. And I just wanted to show that you can really rethink the way we interact with interfaces as well by using machine learning in the browser and detect pose. And you can probably do something in accessibility with this as well. And I am basically over time, but I'm going to stop here. thank you very much. And if you have any question, I'll be at the party. Oh, I'm out. Like, no, I'm done. I love talking about this, so I could actually stay, but I know I have to go. So thank you so much, Cascadia, and everybody for being here with me. Thank you.